Okay, so part of your test, you're going to have to graph, and then you'll have to describe the transformations and do your domain and range. So the first one is the square root function. You're using the parent function of the square root as your guide. And then you're describing the transformation, graphing the function, using a table, I said with at least 4 points, and then identifying the domain and range and set notation. And then when you're labeling the graph, just label a couple of your x and your y axes there. It's helpful just to have it where your points are. All right, so when you are looking at your transformations, if you're using y equals the square root of x as a guide, everything else is going to be a transformation. Okay, so the first one is a negative. Okay, that is what leads to the reflection over the x-axis. Remember, if it's on the outside, it's over the x-axis. The 1/2 is a vertical compression, and it should say by 1/2, not 2. Okay, by 1/2. Okay, and then the vertical translation is going to be 3 units up, and it's vertical because it is on the outside there. Okay, so if it's outside the radical, it is going to be a vertical translation. All right, so for this, because it was just root x, your x's, you could use 0, 1, 4, 9. Okay, so this is something that you'll do without a calculator, so then you will want to have perfect squares. So if you are looking at the work for this, once you know that your x is 0, if you plug that in, you have negative 1/2 square root of 0 plus 3. Okay, so this would be 0 times negative 1/2. 0, 0 plus 3 is going to be 3. If you plug in 1, you have negative 1/2 times the square root of 1, which is 1, plus 3, so you get 2.5. The square root of 4 is going to be 2. What's negative 1/2 times 2? Negative 1. So negative 1 plus 3, 2. Okay? For 9, you have negative 1/2 times the square root of 9 plus 3, which is 3. So this is negative 3/2 plus 3. Okay? You can also think of this as negative 1.5, which is half of 3, so you have 1.5. For 16, you have negative 1/2 root 16 plus 3. 4 times negative 1/2 is negative 2. Negative 2 plus 3 will give you 1. Okay, and then when you're plotting your points here, this one, because of the reflection, is going to be a curve that's going down. Anytime you have a square root, how many arrows does the square root function have? 1. You can't put an arrow on this end because that's not in the domain. Okay? Your domain, you just look under the radical. You're going to set the radicand greater than or equal to 0. Okay, so in this case, your radicand is just x, right? So x is greater than or equal to 0. I don't have to solve for it. Okay, so then you would have x such that x is greater than or equal to 0. Okay, your range, you're going to look at your y values. So your highest y value is 3, and then all of the points are continuing to drop. So this is y is less than or equal to 3. If your graph was going the other way, if there wasn't a reflection, then this would be greater than or equal to. Okay, a good thing to do to practice these would be to go back to your 5-7 homework and do those. Make sure that you do the transformations and the domain and range for each one. Okay, that would be good practice. Questions for me on this one? Number 1? Good. Okay, for number 2, you're using the cube root. Now, because there's no restrictions with the cube root, we know that the domain is going to be all real numbers. With the cube root, the arrows go in both directions. And because your arrows go in both directions, this is going to be all real numbers. Okay? For the range. The domain is all real numbers because you can take the cube root of anything. So you have your y equals, here's the cube root of x, so now we can identify what our transformations are. You have the vertical stretch by 2 in front because it's outside of the radical, and then you have the 1 unit to the left because it's inside. Right? Remember, if it's inside the radical, it's the opposite of the sign that you see. So if you see the plus, it's going to the left. You'll also be able to see that on your graph because normally we're at 0, 0. This is going to move. If you're doing the horizontal translation 1 unit left, remember in the original table of y equals the cube root of x, you can use the -8, -1, 0, 1, 8. The cube root of -8 is -2. Cube root of 1 is 1, so on and so forth. You could just add, in this case you're going to the left, you could just subtract 1 from each of your x values. -1, -1, -1. Okay, and then for the transformations, if it's a vertical stretch, you're going to multiply the y's by 2. Once you plot your points, what I do to curve this is I will start with these 3 points here, and then I'm going to curve that up, put my arrow on, and then I take these 3 points, and then I do my curve, because each part of that is like part of your parabola. Okay, so if it's 1 unit left, you're going to subtract 1 from your x values. And then here, you're going to multiply the y values by 2. Okay, you could also just plug in values that you know are going to get you a perfect cube. So if you do -9 plus 1, that's -8. The cube root of -8 times 2 is -4. Okay, so you can think of it like that. What questions do you guys have on your graphs?